Hey everybody, welcome to Gtcaad. Today we have a 4 Chalk project. It's a component of the Lathe machine. About its application, they are used to hold round, square, hexagonal, or irregular shape workpieces, and can be received to hold work by the inside diameter. And basically it's material made of the VCN 120, or maybe it's made of MO40. Okay, go to the Solidworks. The first part I want to start with the screw bolt. Create a center line. I want to use the shaft option, revolving option. The length of the screw is 70 millimeters and create this shape like me. '21. The gap is 18 and the total length is 70. Okay, I make it the relation between the center line. I got the diameter. It's 21. Our screw is M21. This line and this line should be collinear. Drag here. Sorry, it's M24, the 2 mm pitch. And about this diameter, okay, look, it goes to diameter. If I drag it up, it's show you the radius. It's 15. Okay, it's fully defined. Exit or directly click on revolving bus. Okay. Go to the thread. It wants you to edge of your cylindrical, the edge of your started the thread. I selected this face. Oh, you can make any condition to up to select, for example, this face. We have some option in type. It's inch die. Inch die. You should use an inch die tab. It's for the hole. But about the shaft, if you want to thread it, you should use the die. Here we use the ISO die or metric die here. M24 with the 2 mm pitch. 24 in 2 mm. Okay, the method of the thread is CAAD threading. And about another options, it's completely okay. Look, the first thread, we should make offset because about the 1 mm or 1.5 mm hasn't have a thread. You can make an offset, but reverse the direction about for example 2 mm or 10 mm, it doesn't matter. Okay, it's better. And do it for the opposite side. As I said, end condition here, it's automatically do it for the opposite side because it's saving the memory. Here we should use offset, and about the end and the first starting of thread. Okay. Click. It's better to first edge of our shaft should be chamfer to avoid to cut the hand or make the screw in your hole easily. Okay, drag it your the end design tree up to twice thread and go to the chamfer, but also we make error when we drag our design tree. Here set it to 1mm amount. When I drag at the end of our feature, end of the line, okay, it's appear you the error. Edit the feature because for the age of cylindrical it doesn't recognize because we chamfer it and it moves backward. Select here, okay. About the second, okay. Here our screw bolt is finished, and let's go to the next component. I want to start it, the base of the chuck.
Second part, I want to modeling one of the jaw. Its jaw below has M20 square and has a lot of shape. It has conic, and let's to model it. Okay, sketch and front plane. Draw this shape. Should be perpendicular. Okay, let's dimension it. Here is 22.8. .33 and the total length is 82. About height, here is 7. Here is 18. About the total, we have 57. Escape and pick it again. 57. Okay, it's fully defined. Let's exit. Okay, on the top of our surface, create a sketch, normal to view, create a 3 circle, about the center, it should be on the one straight, it's horizontal. The first one is 9mm diameter, the second is 60, and the last is 30. first edge. Okay, I should make relation. The midpoint and the center of the circle should be horizontal. All the circle make relation about the smallest circle. Okay, make a convert entities, this line, and this line. Here should be coincidence. Okay. Again, about this line should be coincidence. Do it again. Let's check this point and this one should be coincidence. And the last one, coincidence. Okay, Control Z, drag it to right hand again. Okay. Trim entities, the extra line. Yeah, just to cut it this shape. Okay, exit, go to the extrude cuts. Here I want to select up to next. But here I want to make it to this surface. But in select contours, I just want this close profile. Okay. Just this. Look. Again, when you right click under this CAAD, you can share it. When you make a show, you can do another extrude cut based on this sketch. Go to the contour, select just this profile up to surface or this surface. Okay. Again, go to the extrude cut, do it another based on this sketch number 2. Here select this contour and up to next. Okay. Here hide the sketch, see the result, look. But I think we have a mistake here. About this circle, delete it. Last one, theory. Perimeter and diameter, about the center points. Okay, let's change to theory. I think I made a mistake. Yes. Sorry about the number of diameter. It should be coincident and width as the last one. Okay. About this edge from the forward surface, we have chamfer. The chamfer is 10 in 45 degree. Selected this edge and this edge. Okay. But drag the end of design tree, top of the chamfer order. Let's check it. Normal to view, go to the sketch. Here we have some slots. Here, look. I want to create this slot. After that, should the edge be chamfer? And about the back of our jaw, we have some slots here. Look. Okay, this slots cutting is for engagement with the piece and the jack, and for jaws. Draw a triangle. All the line should be equal. Make center line between the edge of rectangular and basement. It should be perpendicular. Okay. Here is 0.89. About the heights and the middle of our triangle is 2 millimeters. Here I want to make a center line to revolving cut our slots and contour. Select here. Okay, the first one, select the center. But I want to, okay, here I made a mistake. Right click on your sketch and edit the sketch plan. Change the plan to middle. Okay, it's a front plan. Run revolving cuts again. Okay, it's done. Look. Change at the end of your designing tree to top of the chamfer. I want to linear pattern these slots. It wants the direction, but if you choose this direction because we want to chamfer this edge, it will make a mistake. Okay, this line is better. It's a direction. And about the feature, I want to cut revolving to 6, and it's the distance between each slot is okay. Drag it under the chamfer order. Right click on the part 1 and change the material. You can select the cast alloy iron, or you can go to the edit material, select one of the steel alloy. But this part is made of the cast iron. Apply, close. Okay. But do it again. For this slot, drag it to top here. Make a sketch on it. Again, rectangular. Okay, I want to exit the sketch. About the color, I want to edit the appearance. It's making noise. uh, this feature I want to do it some slots on this curve surface. You see you have three surfaces that are in curve surface. Here each surface has some slots, but in revolving CAAD feature we have a point, and I will tell you. Okay, go to the sketch, select the mid plane. Here I want to select it front. Okay, select the section view. It makes you a workpiece into half pieces. Select OK, normal, and as I did, create a, sorry, I did reverse, create a triangle. Make this edge to convert entities. Okay, it's selected the whole surface. It doesn't recognize the edge. This point and this point. Edit the sketch again. Okay, doesn't matter, it can recognize. Convert entities again. You can drag it on the points. This edge, this line and this line should be equal. Here is 0.98 as the last triangle dimension should be, and the point is in center line. Okay, I create a center line, doesn't matter how it's height, but about the top of our triangle, this point, and about the center line, that it should be revolving CAAD. It shows us to cut this curve edge. Our curve edge was 90, the radius was 45. Okay, the point just I want to revolving cuts on the surface. We should know about the radius. The radius was 45, and our triangle should be on the same center. Revolving cuts. Select the axis and the contour we selected to our sketch. Okay, exit the section view. Look, it's totally do it, and all curved surface will cut. Okay, go to the linear pattern. It wants to select the edge. Here the feature was cut revolving. Okay, it's create. Again, do it for this curved surface and the last one. We can choose this sketch and share it to another feature. It doesn't need to repeat again. To create a new sketch, you can work with the last sketch and use it for some feature. This line and this line should be equal. Here, okay, look,
Under the convert entities, we have two choices. One of them is for the surface. This face should be entities. I select the intersection curve. Like, look, it's create. This line and this line should be collinear. After that, delete this line and make it infinite to get a fully defined here and here. It's 0.2 and about here is 0.89. Okay, here again the last one was point, should be equal. Under the convert entities we have a surface entities, this line of triangle, okay, and the entities line was collinear. Again delete and make it infinite from this edge. Just click OK here, 0.89, and from the top on this point should be 0.2. Okay, exit. You can show it and make it visible. Here again, but also I forgot it to create a center line for each rectangle. This center line and here. That should be a vertical and has a correct dimension about our triangle. The second surface here was the radius 60 and the last one was 30. Here the radius was 60. Here the radius was 30. Okay, exit. Revolving cuts. But select the contour. Okay, let's check it again. It should totally be slots. The radius was 30. And here the radius was 30. Okay, we have a mistake. About the here, it should be 30. Curve surface related to the D-center. Click OK, exit from the section view. Okay, do it again for the last one. Okay, hide this sketch and just linear pattern.
is 10. About the last one, selected igh, and the feature was the last cut revolve. It should be 7 and 5. Okay, our slots on the curved surface is finished. Let's to create a M20 screw. Okay, I create this slot, cut a slot here, and in original workpiece we have a slot here. Go to evaluate, measure. The length is 72, the width is 10, and the vertical height from the bottom is 11. From the front face it has 70 millimeters horizontal length. Okay, we have it on both sides. Let's go to create this picture. This power screw. When your thread shape or thread figure is a square, it means your screw is power. Okay, sketch on the right plane. Create a circle, 2 dimension, 23. Extrude cuts about 10 millimeters. Okay, I want to reverse it to the opposite side, but we can mirror it. Go to the mirror, select the plane. I create a plane here. It's here, but it's a soft. I do it again. Go to the evaluate, measure to this length, or select this point to this face. It's 82. We want a plane from this face has a 82. It means 41 offset, but it should flip offset. Okay. Under the linear pattern, we have a mirror about this plane, and our feature was this cut extrudes. Okay. Here we have a screw about, look, it's 20 or diameter in 10 millimeter radius. Okay, I want to use Spiral and sweep cut. You can use a whole wizard. It's a little difficult, but the best way is that. Okay, sketch under this face, create a circle about 20 and extrude to next. Okay, again, normal to view, create another circle. It's about we can call it 20, but doesn't matter. To create another sketch, we can use the last one here. Show it. Okay, go to the feature in curves, Under that we have option helical and spiral. Select this sketch. Okay, I think we should create a new sketch. It doesn't accept it. Okay, sketch on it under this face. 20. Exit. Feature spiral. Reverse it. Okay, the first one we use the height and pitch. The pitch was 4 mm, but it should be reverse direction. Okay, normal to view about the front plane. Make a sketch on a front plane. Use a profile thread. It should be square 2 mm or it should be 1. 1 in radius, 2 mm in diameter. As a depth of our thread. Select on it, convert entities. It should be for construction. About here, it should be 20, but also it's 10, sorry. So let's delete this relation coincidence. It should be 10. Okay, exit, go to the feature in Gtcaad. Select this feature as profile and okay. The best option is bidirectional. It cuts it to your spiral end. Okay, let's see the results. Height, the spiral. Okay. Look, our power screw is create. Go to the evaluate. The radius is 10. Okay, just one option is remaining to complete our piece is about 13 fillets, 0.9. These all should have fillets because it's a way to damage our workpieces when the old jaw stick workpieces. Okay, our jaw is finished. Let's go to the base our jaw fork. Okay, our jaw is finished. Let's go to the next component. Okay, this is the next component. All four jaw are fixed on it. I want to modeling in a short way. Okay, let's go to the model. Yeah, create a
center line. For each circle, it's a best choice to use the revolving boss base. You can model it in a extrude boss, but the best way is use the revolving. It make your way shorter. The diameter was 200 and about height is 70. 200 and it's 70. Okay, use revolving boss base. The top and below surface has a 2mm radius flat. Okay, section view. I want to create. We have some slots, circular slots on it. Again, use a revolving cut. Yeah, create a sketch on front plane. The first step, draw a center line, and I want to create some triangle. We need to create 3. Okay. All lines should be equal. And all top edge should be on a horizontal. Okay, just use the center line. This and this should be perpendicular again. Both chord line and base line should be perpendicular. And this line, and this line is equal. Okay. Let's dimension it. The first one has a diameter 94.2 and the second is 129.21 and the last has a diameter about the center line is 63.79. Okay, it's 2 millimeters. Let's revolving cut. Select the axis. Okay, look. It's short and easy way. Okay, let's do it again. Section view. Make a sketch on the front plane. Center line and create this sketch as I did. Okay, when you back to the start point, it's reverse to arc. Half of the sketch is enough, you can mirror it. should be coincident. Okay, we can delete it. Let's dimension it. Here has 27, 19.34. The height is 10 millimeter. Sorry, it's 11.2. This length is 10. The diameter is 12.05 in 2 times. About the center, we have a height is 39.05. Make relation should be on the center, coincident of center of a circle. Here is 5. About the last one is 32.7. Okay, you can mirror this line, mirror about the center line. Okay, you can trim the extra line and close our sketch. Okay, exit, or you can directly select an extrude cut and select it through all bobs. Exit. Okay, I want to circle a pattern this feature about the outer surface. Our feature is here and the outer surface is here. It's just about to sample. It's 90 degrees. Okay, our feature is cut extrude. It's selected in the wrong way. Okay, let's check the original workpiece. It has a lot of hole here, look, and have the slot cut here as the top surface. The bottom has 2 of them. We have some circular slots in jaw below. Let's show you in a original workpiece is here. We have some circular slots. Normal to view. Front plane, create a sketch, section view. Okay. Create this profile. Create a center line because I want to use a revolving cut option.
This angle should be 45. Here is 45. Okay. $175. $170.60. $109.45. Right. Go to the revolving cut. It automatically select axis and our sketch. Exit from the section view. Okay. Here we have some hole. The big hole is cut. Extrude through all is 57 diameter. It's total cut extrude. Okay. Here we have some hole. Go to the hole wizard. It's a counterbore hole. Select here. 20 is this about the diameter. I change it to 9 millimeters. About the depth, it's 100 millimeters is okay. And about the C-bore diameter is 40 is here. I change it to 16. And about the depth is 20 is here. I change it to 10 millimeters. We can end condition into true all. Also, we can use another option is the here counterbore, but yeah, you can select on the legacy hole. All dimension can change it. Create a one. I use a circular mirror about the rest. Center line. But also you should check it should be on a ZX plane. Okay. It should be 75 about the about the z-axis it's 75 and here it's 15 about the horizontal or x-axis. Should be on a pitch diameter. Diameter is 82. Okay, it's fully defined exit. Our hole is create just circular pattern this hole into 3 number of this hole. Feature is our hole 3 and angle should be right. It's great. Between each holes we have a 120-degree space. Go to hole wizard again. Select again here on a legacy and on the counter board. Yeah, it has a lot of options. You can see the diameter 20, change it to 6 pips. Like it's error because it shows us some dimension are not in value. Or we can change to a C-board. It has a lot of options. Okay. The diameter 20, change it to 5. Depth it's 100, should be change it to 7 millimeters. The C-board diameter is 40, change it to 11. About the depths, okay, the point was about the end condition, we should change it to blind, that we can change the amount. 40. This should be align the X axis. The coordinate our hole is 30. The circle should be for construction. Diameter is 78.1. Like exit. Go to the circular pattern. We need to have 3 number of it, about the feature hole number 2. Okay. Let's check the other feature. Okay, our model is done. We can change the material.
بهنام شماره کارتشو بده به
آره.
اونو برای من SMS کن.
Okay, change the material to cast alloy steel. Okay, we have just one component remain to model it. After that we go to assemble all components. Okay, the Cylindrical pin remains the model. I want to model the cylindrical. It has a lot of feature as machinery. Okay, go to the sketch, select the front plane, create a center line, and draw just half of the cylindrical surface. You can trim it and extend the center line to merge our line. Dimension it. The diameter of the bottom shaft is 9.85. The height is 15. Okay, it's on a diameter dimension. It's default on diameter dimension. The first finish all the diameter 15.9, and just one remain. It's here is 8 millimeter. Okay, press the escape key. Let's dimension the height 15. Okay, just drag it up. From this height is 3, and about this line and this line is 37.5. Go to the feature and select revolve. It's warn you that your sketch is not close basically, and he does it for you automatically. Okay. We have chamfer on the top of our shaft. It's 1 millimeters. Press Ctrl 1, number 2. Okay, keep the control when you push the number key, for example, Ctrl 5, 6. It change the view. Section. Okay, exit. Again, section on this face. The face stick on the front plane. Create arc. The radius of arc is 12.5. 12.5. About the dimension of the center has a length about origin is 12.5, or sorry, delete it. About the top of the cylindrical has a vertical dimension about 17.5. About the horizontal, it's 12.5. Okay, just close our sketch, trim the extra line. Okay, you can recognize the cylindrical surface. Under the convert entities we have intersection curve. Okay, when it select the face, you can collinear. Okay, exit. Yeah, this line and this line should be collinear relation. Like clean the extra line. Okay, go to extrude cuts. We can select it through ovals. Okay, exit the section view. Again, select this face, sketch, normal to view, and our arc should be here. Look, it should be about one axis. Both arc axis should be collinear. The radius is 5.5. And about the horizontal between the origin and the center is 11.5. And make the relation horizontal, convert entities, and clean the extra line. Exit, go to the extrude cut and make it 9.3. Change the material, cast iron, rebuild and save. Okay, time to assembly. Press Ctrl N and create a new assembly. Here, insert the chuck body. It's the main body. Okay, it's fixed. You can right click on it and float. Make a relation about the three main plane assembly. But now it doesn't matter. Let's insert the other component. The first one is spindle screw. I can make a relation. The first one, make a relation concentric. And tangent. Okay, you can make it in circular pattern. Or in 360 degree. So you can select in a quad. Okay, when you rotate one of them, or screw about its axis. Insert another component. I want to insert about the jaws. I can rotate about the y-axis. Mate in mechanical mate, we have a screw option. Click on it on the screw power, and you can select one of the cylindrical surface in jobs. Okay, make another relation between this face and this face should be parallel. Okay, look. Again, we can circle pattern this jaw into 4 jaw. 1, 2, and 4. Okay. Look. When you drag it up and down, the others will lead from the first jaws. Okay, there's another component. We have a Allen bolt or lock pin. And there's another component. Select the circle cylindrical surface. Okay, I should reverse it. I made a mistake, sorry. About 3 mate veto. Change the switch to place. It should be here. The Allen bolt should be here. Okay. Make this relation concentrate. This face and this face. Also, we should have this line okay. It's better. We can do it for another. Oh, sorry, we just need 3. The remain hole should be stiff on a lathe machine, and totally our 4 jaw chuck, our model is finished. I hope you enjoy and learn some feature from Solidworks. Please share it to your Solidworks guys if you like it, and don't forget to subscribe to the channel. Thank you very much.